Hey everyone, welcome back. So in this video, we're gonna continue from what we talked about in previous parts of the session in regards of the topic of fine-tuning your neural network model using multiple GPUs. So with that being said, let me share my screen. And for the sake of scope of the class, we built this platform called wing360search.com. It provides multiple GPUs at the tip of your finger completely for free. So let me refresh my screen and let me fire this up. And then I will show you what the pipeline look like. And while we're waiting, let me give you a recap. So previously we talked about how to load up your DeepSpeed pipeline, right? What exact package you need to install, dependencies you need to install, what are the steps that you need to do to fire up the training process. And then you can then track the performance on weights and bias user interface. So we have a whole pipeline discussed, but the model that we saw in previous video didn't work out well, right? There's an improvement strategy. So today we're going to go to that improvement strategy just to give you guys a couple of different highlights and different tools so that you guys can know what is used, what is not used. And based on experience, sometimes these things could come in very handy, right? And just in the beginning, I want to say this, that sharp eye, right, from a data scientist that's able to look at the data and use his own experience or her own experience to just, in a second, quickly be able to tell, okay, this strategy works, this strategy does not work. That is a very valuable insight. That is a highly valued piece of experience that up to day and age to today, it's still skills belong to human, right? There's no machine that's magically going to know that. So hopefully in this video, I can show you guys what that looks like and what that feels like using a small toy model. I can kind of pinpoint what the sharp eye mean in a simple scenario, and hopefully you guys get a holistic view and get 100% clarity of what do I mean by that. And even data science as a domain can change and can shift its definition and its workflow and its efficiency. From conventionally, we build logistic regression, linear regression, support vector machine, all the way to perhaps to neural network, to large language model. That sharp eye trait, it's still very rare in pretty much any domains. And then, that's why I want to do this video because I want to show you guys what do I mean by that. And even if you go to the course topics one by one, right? Model selection, support vector machine, all that stuff, it still does not beat human intuition. A human intuition still holds the highest ground of what strategy is working, what strategy is not working, and hopefully in this video I will show you that. So we're gonna wait a little bit. We're gonna come back and we're gonna fire up JupyterLab to show you guys the content of the improvement strategy that we can use to fine-tune a neural net. Okay, so now this is fired up. We can say JupyterLab is working, and we can go to terminal window, and let's get things started. The best way to do it is to go to MNT mount, and then inside that we can probably git clone. The package is here, github.com, and up here we say DeepSpeed course. And this is the URL that we are going to clone. I'm going to put that there. It will copy the entire folder down to that mount drive. Great. Once that's done, we can make things a little bit more prettier. We can go to full screen. Awesome. And then from here, we can do our thing, right? DeepSpeed course. We can do the same on the left-hand side directory so that we are in a clean slate. We can go to 01, basic neural net. And here's what we're talking about. We can go to model improvement and put on the right-hand side by side, and you can read through these documents to see what's going on. Previously, we talked about the performance is very poor. And let me just jog your memory a little bit, right? Previously, we talked about a very simple model, linear model, just neural net package, linear. That's it, right? Just one line of code. And the data is y equals to 2x plus 1, and you better be able to have 2 and 1. Otherwise, it's wrong. We did not get 2 and 1, and obviously something's wrong. So the way I like to do things is I will pip install UV. This will allow me to manage the virtual environment altogether in a sandbox session. And now, of course, this is just a good habit, right? You can use poetry, you can use pretty much anything else. PyIn is another good one. You can use pretty much whatever you prefer. In this case, I typically use UV. So that's how I like to get things started. Then we're going to install the package. Next, what I would do is go to the Markdown file on the main directory here in this folder, and then we can go to the steps of what to create. So the best way I find is to use UV init, a project, and then we can copy a couple of files into the project. In this case, I will copy the configuration file into project folder, and then I will copy the enhanced training Python script into the project folder. And then I'm gonna cd into the project folder, and then I can install all these packages. So UV add, oops, UV add torch. That's the first thing that I'll have to install. After that, I will have to install DeepSpeed. I always install weights and bias. So I'm gonna go ahead and do that. So now that we installed Torch by using UV add, I am going to install DeepSpeed, and that is the two most important package that we're going to install. And Torch will give you the neural network, right? The linear layer, the attention layer, all of the bells and whistles that goes underneath a neural network model, right? DeepSpeed will give you the configuration, will give you the software to help you come up with the configuration that you want to allocate your model, the data, the weights across multiple GPUs. So that's the framework, Torch and DeepSpeed. Once you have those two things, you can cover a lot of ground, right? Now I think sometimes we need to add setup tools. Now this is interesting. Sometimes I need it, sometimes it doesn't. Kind of depending on how this image started. So I'll have to take deeper look into how to streamline that. But in this case, I do believe we need it. So UV add setup tools. And last but not least, weights and bias, right? So UV add weights and bias. And this will give you the API access to help you track the observability of the model performance. So that's awesome. Now we are here and we can put in our API key for weights and bias. I'm going to pause the screen and come back. Great. So I just put in my API key for weights and bias, and you will need to do that. So this will allow you to track the performance. Once that's done, let's go back to full screen. Let's take a look at what we're working with. So on the left-hand side, we'll go to Mount, DeepSpeed, session 01, project folder, and we have our configuration file. We can open that. And then this 32 obviously need to be changed. We also have our Python script. So Python script has a couple of things here that's interesting. Previously, we talked about a very simple model. Let me show you what the model look like. It's just a linear model, right? And then we have data loader. That's pretty much it. Very simple model, very simple data, but the performance is not good. So we want to improve the performance. And then here's what's going on, right? Here's a caveat. And here's probably the most important thing of today's lesson. So when you have a data, when you have a model, and you send the data to the model, you're trying to fine tune it, it does not work, right? That's a very real world experience. That's a very real world question. What do you do, right? What do you do? Now, depending on how big of an AI user you are, if you're not a big AI user, you can read a book, right? Statistical machine learning, whatever textbook you can cook up, right? Feel free to go to read the book. It's not going to tell you the answer. Um, Now you can also ask a more experienced data scientist or more experienced engineer or your teacher or professor or your boss, right? For that matter. You can say, hey, this does not work. What do I do? Right? Um, if obviously depending on your relationship with the other person that you're asking, hopefully it worked out well and you guys have a constructive conversation. But if you're a data scientist and you're getting paid to do this, it's kind of up to you to figure that out. And most likely, your boss that's having meetings with the executives all day long are worrying about uh, things that's probably not going to be down to this level of granularity. So even if they are experienced, even if they have their PhD, they probably have their PhD 10, 20 years ago. And some of these stuff, they just may not have the answer, right? So it's kind of up to you, and I will probably even argue it's kind of the responsibility of the data scientist to figure that out, right? It's kind of your job to look at the data, look at the model, and figure out these eight things are possible strategy to improve your performance. That's why we're here today. I want to talk about this a little bit, right? It doesn't matter how you get this list. You can ask ChatGPT, you can ask an experienced person, you can ask your boss, you can read the internet for 5 hours. Doesn't matter how you get this list. What's matter is how do you distill the information in the list and how do you know what's optimal, what's not, right? There's no right or wrong answer. Look, you have a simple data, you have a simple model. In the beginning, one of the things that people probably gonna say is, train for longer, right? Train for longer, like 1,000 epoch, 2,000 epoch. That's kind of like a no-brainer, right? Is that going to increase the performance? Probably not in this case, right? So you ask ChatGPT, textbook, some experienced data scientists, somewhere down the road, they're going to be like, oh yeah, one idea is, early stopping, right? So, or increase the early stopping so that the model train longer, right? It's up to you and your knowledge and your experience and your sharp eye to be able to tell whether that recommendation is appropriate in this scenario, right? You have the rationale, you have the data, you have the model, you have the computer code, right? The other person just kind of like trying to brainstorm with you. They may or may not have the big picture. So in this case, right off the bat, you can say number five probably does not do a whole lot with the model performance, right? So that's what I want to talk about. Same goes with the other thing, right? In this code, I implemented all eight strategies, right? And as a matter of fact, if you go back up to 0, 1, you can go to model improvement and you can read this whole thing, right? This whole thing has method one. Down here, you have method two, three, so on and so forth. I think if you scroll all the way down, there's probably like 10 different methods, right? 10 different methods of helping you understand, okay, here's another thing you can do to increase the performance. Whether that's going to increase performance, that's a trial and error. So let's see how it works. Now that we finished installing everything, I believe I can go ahead and start a run job. So here we're going to say UV run DeepSpeed. The argument here is non-GPUs. Here I'm going to set as 2, and then I'm going to call the script. So train DS enhanced.py. And then in the case we have 2 GPUs, this configuration file need to match up. So let me show you what I mean by that. Let me go to project folder. Let me go to this JSON file editor. This 32 needs to be 64 because the train batch size need to be the product of this micro train batch size per GPU, gradient accumulation, and the whatever number GPU that you have. So if you have 2 GPU, 2 times 32 times 1 is 64, then this number needs to be 64. Awesome. Now we can run this code. And I already have my weights and bias API key exported. So once we go through this training job, hopefully it will be able to save the weights automatically on the user interface of weights and bias. So let's see how that works. And just in case you guys interested, we can open a new terminal and then we can kick off the watch session. So we're gonna say watch 0.1, NVIDIA, SMI, to kick off this, just so we can monitor the usage here. This is not a crazy model, so a couple of epoch, a couple of spikes, a few percentage here and there. That's pretty much what we're talking about. And once it's done, we can then click out this link here. So what I'm going to do is copy this, and then I can go to a new URL. So here, this will be able to show me what the performance is on weights and bias website, and we're going to evaluate how accurate this is, right? So that code is there, and then we can see, okay, the loss is going down, and the patients here is stopped, great. Steps is continuing, great. Error for weights, error for bias, both are going down, awesome, right? Awesome. The most important thing is a step loss. Step loss is going down, awesome, right? That's what we're talking about. It's going down, it's learning. Finally, we got to a place that's near zero. Excellent. So that's what we're talking about. And then I think that's what makes the session interesting, which is you have a list of plan, and then this list of plan, you can implement it, and then you can reduce your error of the model. Now, one thing I want to say is the following. Technically speaking, I really did not make it clear which of these methods do I use, which of these methods do I not use, right? If you look at this enhanced training script, it actually has all of the improvements integrated, which for obvious reason, this is like an overkill, right? It's obviously an overkill. And my question for you guys, and I'm not gonna show this in video because I want this to be a exercise, is if you have time, it will be a really good learning experience to figure out which one of these actually increase the performance, right? And either you have that sharp eye, or if you don't have a sharp eye, then you can try out every single one of them. But then the idea is, well, you should just move one piece, run to the experiment, and see what the performance is, right? If you try two of them or three of them, or in this case, all eight of them, then you don't really know what's working, what's not working. Okay. So I want you guys to, have all the tools, right? Here you go. That's the code. Wing 360 search platform is there. Please have at it. Please use it. And essentially, it's like a gamified version of um, collecting that extra layer of experience for yourself. So let's finish here. I just want to throw that out there. It's a good exercise if you have the time. If not, we'll make it optional. But it will be a really good exercise if you can train yourself and just have that sharp eye to be able to tell which is which. It is not a experience that I can just say it and then you'll magically know. Unfortunately, that does not work that way because this experience is highly empirical. It's highly dependent on what model you're building and what data set you're using. Let's say you've gone through the experiment, you trial and error each and every single combination of all eight of them, right? Let's say that's the case. And you magically figure out, oh, method two is the best method. Is that experience applicable tomorrow in the new data or next week in the new model? Probably not, right? Probably not. No one in their right mind will be able to say, oh yeah, change your learning rate and then absolutely you will 100% have like a 90% performance gain, right? No one in their right mind will say that, right? It's highly dependent on what data you use. It's highly dependent on what GPU you're using. It's highly dependent on what model you're building, right? So unfortunately, it's not something I can just tell you in a textbook or I can just tell you in a video or in a class session. You have to collect that experience yourself. And you're not going to have that experience if you're just listening to me or, if you are listening to somebody else. That experience can only be collected from running the model yourself. And personally, myself included, right? In my early days as data scientist, that's how I get started. You're just spending time. That's all there is. Find a good GPU, spend the time, thousands, if not tens of thousands of trial and error, you'll be able to collect, train yourself to have that sharp eye. Other than that, unfortunately, there's no other good ways around this. So again, uh, uh, tell you guys what direction is. Now, of course, it's up to you guys to run the experiment or not. So thank you for watching, and I'll see you guys in the next video.